Hi, mathematicians. In this lesson, we are going to learn about writing equations of quadratic functions. After this lesson, you will be able to write the equation of a quadratic function from a graph. So we're going to be writing equations given a graph, and we're going to still use Vertex form of a quadratic function, and it looks very similar to our absolute value. We have our a value and our h and k, a times the quantity x minus h squared plus k. So what we need to get from a graph like this would be its hk, which if you remember is the vertex. So down here at the vertex, that's always going to be hk that we can plug into this equation up here. So we need the vertex. Write that here, that's what you're putting on your paper, which is hk. And we also need the a value, which is going to be our first step. So where do I cross the next time is right here. That's where it hits on a grid mark in both directions. And so that's 1, 2, 3, 4 in this case would be the a value. So you're always looking for that first step. So for these types of problems, we write the equation of the quadratic function that's graphed below. You're going to do all the same things by identifying the vertex, the a value, and whether it opens up or down, and then translate that into the equation. So our vertex is 3, 2 for this first one. And so you'd write that in the space here. And we know that it's opening up, which means our a value is positive. And to find the a value, you are simply going up and over. So this is going up 2 over 1. So we know our a value is 2. You can write that as 2 over 1 if you want. It is positive because it's opening up. And then you're going to use our vertex form of the equation. Y equals the a value 2, x minus h, our h is 3, squared, can't forget that or it's not quadratic, and then plus k, which is 2. And we can double check, but we should see that I have a plus 3 here, which means I have a minus 3 in my parentheses, and I have a plus 2 here, and I have a plus 2 on the outside. Looking at question 2, again, we're going to find that vertex. In this case, the x is 0 because I'm not moving it left or right at all, and it's up 7, so the point is 0, 7. My a value is, and you're just going between the first step, so I go up 1 before I go right or left to the other point, so my a value is 1. And I'm opening down, which means that a value is actually negative 1. So my equation is going to be y equals, my a value is negative 1. You can put that as a negative 1 or just that negative sign. Normally you would have x minus the h value, which is 0 in this case. You don't have to have the minus 0 because it's just 0, and then plus k. So this could look just like y equals negative x squared plus 7. Either one of these is perfectly correct. I would accept both of those. Looking at question 3, again, we're going to identify the vertex. We can see that right here. It is negative 5, positive 7. Remember that this is always x comma y. And if you need to label those x and y axes as that reminder, it is opening down, which means our a value is negative. And to get that, you're going down. How many do you go down to get to the next grid point, the next perfect point? And so it's going down 3, and it's negative 3. So our equation is y equals our a value, negative 3, x minus negative 5, which is the same thing as x plus 5. Remember, the sign is always opposite. And then plus k plus 7. And it's a, you can see here, if it is a minus for the x, it is going to be the opposite sign, so plus here. If it is a plus here for the k value, or in the y spot, it is going to be a plus. That stays the same in your equation. Taking a look at number 4. So again, our vertex is hitting down here. It is to the right 4, and it doesn't go up or down at all, so it is at 0 for the y. Always write the vertexes in ordered pair. It is opening up, and I'm going up and over 1. So you can write that as 1 over 1 or just 1 for your a value. Y equals 1. You can put the 1 there if you want, but you don't have to. X minus 4 squared, and then you can put plus 0, but you don't have to have the plus 0 because that doesn't change the value for the y value. So again, noting, I see a plus 4 here, so it's a minus 4 in my parentheses. I have to have the square, and then plus k with 0 is a 0 there. You could also write this as y equals x minus 4 squared without the 1 in front because that stealth 1 is still implied there, and without the plus 0. To summarize here, and you can screenshot if you want this image if you don't already have it, but our vertex form is a times the quantity x minus h, that's being squared, plus k. This negative, the subtraction means opposite for when you write your ordered pair. We have our direction and we have our first step with the a value, and then this is our vertex. So when you're given an equation, you're just working backwards here. You're finding the vertex, which is -4, +5. When you put that in the equation, it's x minus a -4, which changes its sign to +4. Again, noticing that they're opposite. As long as you remember the opposite, you'll be okay. And then this is +5, so it's +5 here. And then to get your a value, you're noticing that it's opening down, so that's why it's negative, and you're counting the steps. So I'm seeing that this is 3 for that first step. This is down 3, right 1. And so that's where that is -3 in our equation.